Welcome everyone. I'm excited to kick off our session today with the Certificate in Pedagogy Foundations. Today, we'll be focusing on Module 2, Learning Theories and Educational Psychology. Over the next few moments, I'll give you a quick overview of what we'll explore together, including key learning theories and how they apply to educational psychology. So, let's get started and make this a meaningful learning experience. Let's start by looking at how we store knowledge for the long term. This is all about retention, how our minds keep information accessible over time. Think of it as the mental filing cabinet where important knowledge is saved for future use. Next, we have internal mental work, which is crucial for organizing that information. This process helps us make sense of what we've learned, connecting new facts with what we already know, and making the knowledge easier to recall later. Then there's processing. This is how knowledge is first encountered and received. It's the initial stage where we come into contact with new information, whether through reading, listening, or observing. This is a vital step because the way we process information initially influences how well we retain it later. And finally, we have acquisition, the actual introduction of new knowledge into our mental framework. Understanding these stages, processing, acquisition, and retention, helps us grasp how learning works overall. These concepts are central to learning theories because they explain the journey of information from first encounter to long-term memory. So, as we move forward, keep in mind that effective learning involves not just receiving information, but actively organizing and consolidating it for the future. Today, we're looking at a fundamental idea in behaviorism, the assumption that behavior is shaped entirely by the environment. This perspective suggests that individuals start as a blank slate, meaning we're born without built-in tendencies, and all our behaviors are learned through interactions with our surroundings. Learning, in this context, is seen as the formation of associations between stimuli and responses. Essentially, when a particular stimulus occurs, it triggers a specific response because we've learned to connect the two through experience. This brings us to the stimulus response model, which focuses exclusively on observable actions, what we can see and measure directly. It emphasizes that the key to understanding behavior lies in these measurable responses to stimuli, rather than internal thoughts or feelings. All of these ideas are central to behaviorism's core principles, which prioritize observable behavior and environmental influences. By concentrating on these aspects, behaviorism aims to provide a scientific, objective approach to understanding how behavior develops and changes. Throughout this presentation, keep in mind that these principles form the foundation for many behavioral theories and interventions. They help us understand how behaviors are learned and how they can be modified through environmental changes. Let's take a closer look at some types of behaviors we observe in learning processes. First, we have voluntary behaviors, which are actions we choose to perform, like completing homework or raising our hand in class. These are different from involuntary responses, which happen automatically, such as reflexes or reactions to stimuli. Now, in teaching and learning, we often use focus and praise to reinforce positive behaviors, like praising a student for finishing their homework. Similarly, a bell signaling the start of a lesson helps students associate that sound with beginning their class activities. To understand how behaviors are learned, it's helpful to look at some classic examples. For instance, Pavlov's experiments with dogs demonstrated classical conditioning, pairing a neutral stimulus like a bell with an unconditioned stimulus like food to eventually elicit a conditioned response. On the other hand, B.F. Skinner focused on operant conditioning, which involves learning through reinforcement and punishment. Here, behaviors are shaped by their consequences. Rewards encourage repetition, while punishments decrease unwanted behaviors. The process of pairing neutral stimuli with unconditioned stimuli is fundamental in classical conditioning, creating associations that influence future responses. Both Pavlov and Skinner contributed key insights into these mechanisms, which form the basis of many behavior modification techniques. When we look at conditioning models, we see how these mechanisms serve as frameworks for understanding learning. Classical conditioning explains how involuntary responses are learned, while operant conditioning explains how voluntary behaviors are shaped and maintained over time. These models are essential tools for educators and psychologists aiming to influence behavior effectively. Let's start by talking about extinction. This is a strategy where we simply ignore outbursts or challenging behaviors. The idea is that if the behavior isn't reinforced or rewarded over time, it tends to decrease or stop altogether. Next, we have token economies, which are really effective in encouraging positive behavior. In this system, students earn tokens or points for desired behaviors, and these tokens can later be exchanged for rewards. It creates a clear link between actions and consequences, motivating students to stay on track. Shaping is another important concept. It involves rewarding small steps toward a larger goal. So, instead of waiting for a perfect behavior, we acknowledge and reinforce incremental progress. This helps students build confidence and gradually develop the skills we're aiming for. Now let's look at classroom tools. Negative reinforcement, marked as R with a minus sign, involves removing an unpleasant stimulus when the student exhibits the desired behavior. For example, reducing a difficult task if the student cooperates. On the other hand, positive reinforcement, noted as plus R, means adding a pleasant stimulus to encourage the behavior. Giving praise or a reward when a student behaves appropriately are common examples. Finally, reinforcement strategies are the overarching methods we use to shape behavior effectively. Whether it's through extinction, token economies, shaping, or reinforcement types, the goal is to promote positive, sustainable behavior changes. All these tools and strategies are interconnected and vital in creating a supportive learning environment. Let's talk about a common pitfall in motivation, over-relying on rewards. When we focus too much on external incentives, it can actually weaken our natural curiosity. Essentially, it shifts attention away from the intrinsic desire to learn or solve problems, and instead, people start doing things just for the reward. This leads us to what I call intrinsic loss, which ignores the internal processes that are crucial for genuine understanding. Things like problem solving, emotions, and internal thinking. These are all vital parts of learning that get overlooked when we depend solely on external rewards. When internal thinking is neglected, learners often settle for surface learning. They might memorize facts just enough to get the reward, rather than truly understanding the material. This ties into the limitations of behaviorism, which emphasizes external stimuli and responses. While rewards can shape behavior temporarily, they don't foster deep thinking or internal motivation. So the key takeaway here is that over-reliance on rewards can hinder the development of authentic curiosity and meaningful learning. Instead, we should aim to engage internal processes and foster intrinsic motivation for more sustainable and enriching education. Learning is an active mental process, meaning that our minds don't just passively absorb information. Instead, we engage with it, analyze it, and make sense of it through active thinking. When we talk about memory, there are different types to consider. Long-term memory is like a vast, permanent storage system. It holds all the knowledge and experiences we've accumulated over time. Working memory, on the other hand, is more like a mental scratchpad. It's where we actively manipulate information for about 15 to 30 seconds, like when we're doing mental math or remembering a phone number just long enough to dial it. Then there's sensory memory, which captures brief snapshots of environmental input. Think of how quickly your senses register what's around you, but that information only lasts for a fraction of a second unless it's processed further. All of these types of memory relate to how the mind functions as an information processor. This perspective is central to cognitivism, which emphasizes that learning involves active mental processes, such as encoding, storage, and retrieval, rather than just passive reception. Recognizing these different memory systems helps us understand how learning truly works and highlights the importance of engaging actively with information to make learning effective. Let's take a closer look at some key concepts that help us understand how we process new information. First, we have advanced organizers, which are tools or strategies we use to connect new material to what we already know. This helps us make sense of new ideas more easily. Next, we have accommodation. This is when we modify our existing schemas or mental frameworks to include new information that doesn't quite fit with what we already know. It's like updating our understanding to incorporate fresh insights. Then there's assimilation, which is fitting new information into our existing schemas without changing them too much. It's about integrating new data into our current understanding seamlessly. All of these ideas are rooted in schema theory, which suggests that our knowledge is organized into these mental structures, these schemas, that help us interpret and remember information. Think of cognitive structures as the mental frameworks that shape how we understand the world. They're essential because they influence how we learn, interpret, and recall information. So, by using advanced organizers and understanding processes like accommodation and assimilation, we can see how our minds actively work to link new knowledge to what we already know, making learning more meaningful and effective. Let's take a closer look at some key strategies and concepts that support effective thinking about thinking, or metacognition. First, we have strategies like think-alouds and journals. These are practical tools we can use to become more aware of our own thinking processes. For example, when we use think-alouds, we're verbalizing our thoughts as we work through a problem, which helps us reflect on our reasoning. Journals, on the other hand, give us a space to write down our thoughts, insights, and questions, fostering deeper self-awareness. Moving on to regulation, this involves planning and monitoring. Planning is about setting goals and deciding how to approach a task, while monitoring involves checking our progress and understanding along the way. Both are essential for staying on track and adapting our strategies if needed. Next, there's the concept of knowledge, specifically, understanding our own strengths. Knowing what we excel at helps us leverage those skills and build confidence. It also guides us in recognizing areas where we might need more effort or support. All of these ideas tie back to the broader theme of thinking about thinking. Metacognition is really about being aware of our mental processes, understanding how we learn best, and actively managing our thinking to improve outcomes. When we develop these skills, we're better equipped to learn effectively and solve problems more efficiently. So on this slide, we're emphasizing that learners really build meaning through experience and inquiry, rather than just passively receiving information. This means that active engagement is key to deeper learning. You'll notice we highlight project-based learning, or PBL, which is a great example of this approach. Instead of simply listening to lectures, students work on real-world projects that require them to explore, ask questions, and discover solutions. We also see the term knowledge construction. This is about learners actively constructing their understanding as they engage with new information. DIY, or do-it-yourself, encourages learners to take ownership and hands-on approach to their learning process. All of these ideas connect to constructivism, which is fundamentally about active learning. It's the idea that learners aren't just passive recipients, but are actively involved in making sense of their experiences. This approach shifts the focus from memorization to meaningful engagement, aligning perfectly with our overall theme of fostering deeper, more personalized learning experiences. Now, let's take a closer look at some effective collaborative learning strategies. First up is group inquiry, which accounts for about 30% of our approach. This method encourages students to explore topics together, fostering curiosity and deeper understanding. Then, there's Think, Pair, Share, also at 30%, a simple yet powerful technique where students think individually, then discuss their ideas with a partner before sharing with the larger group. Moving on, the jigsaw method makes up around 40%, and it's particularly effective for promoting interdependence, as students become experts on different parts of a topic and teach each other. All of these strategies revolve around the core idea of co-construction, meaning students actively build knowledge together, rather than passively receiving information. And underpinning all of this is social interaction, which is essential for creating a dynamic, engaging learning environment. These methods not only enhance understanding, but also develop critical social skills, making learning more collaborative and meaningful. So, by integrating these strategies, we're really emphasizing the importance of working together to deepen learning and foster a sense of community in the classroom. Now, let's take a closer look at the different types of real-world learning experiences. First, we have field research, which makes up about 35% of our approach. This involves students engaging directly with real environments, gathering data, and observing phenomena firsthand. It's a hands-on way to connect theory with practice. Next, business simulations account for roughly 30%. These are immersive, interactive scenarios that mimic real business challenges. They allow students to apply their skills in a safe, controlled setting, helping them develop decision-making and strategic thinking. Finally, community issues represent about 35%. This aspect emphasizes addressing real problems faced by communities, fostering a sense of social responsibility and relevance. It encourages students to think critically and contribute meaningfully to society. Overall, these authentic, real-world contexts are essential because they bridge the gap between classroom learning and practical application, making education more engaging and impactful. They ensure that students aren't just learning concepts, but are also prepared to navigate and solve real-world challenges. Let's talk about observational learning and modeling, which is a really powerful way we learn from each other. This falls under the broader concept of social learning, meaning we often pick up behaviors by watching others. When we observe someone else demonstrating a behavior, we can learn and even imitate that behavior ourselves without needing to go through trial and error. This process is key because it shows how social environments influence our development and choices. Think about how children learn language or social skills by watching parents, teachers, or peers. It highlights the importance of role models in shaping behavior. What's really interesting is that this form of learning helps us adapt quickly, sometimes faster than if we learned only through personal experience. So, in the bigger picture, observational learning and modeling emphasize how much our surroundings and the people we watch impact our behaviors and attitudes. It's a fundamental part of how we learn within social contexts. So, when we talk about self-efficacy, we're really referring to the belief in our own ability to succeed. This belief isn't just something we're born with. It's developed over time through various experiences. One of the most powerful ways to build self-efficacy is through mastery experiences, those moments when we successfully complete a task or overcome a challenge. These successes boost our confidence and reinforce the idea that we can handle similar situations in the future. Another key source is vicarious learning, which happens when we observe others succeed. Seeing someone similar to us succeed can inspire us and make us believe that we too can achieve similar outcomes. It's a really effective way to expand our belief in our abilities. And then there's verbal persuasion, encouragement, and positive feedback from others. When someone we trust tells us we can do something, it helps us build that inner belief that we're capable. All these elements, mastery experiences, vicarious learning, and verbal persuasion, together create a strong foundation for self-efficacy. Remember, this belief in our ability to succeed is crucial because it influences our motivation and how we approach challenges. When we truly believe we can succeed, we're more likely to put in effort, persist through difficulties, and ultimately achieve our goals. So, building self-efficacy is all about nurturing that confident mindset, which is essential for growth and success. Let's take a closer look at Piaget's stages of cognitive development. Starting with birth to 2 years, during the sensory-motor stage, infants develop object permanence, which is the understanding that objects continue to exist even when they can't see them. This is a foundational milestone for their sense of the world, and they learn a lot through their senses and actions. Moving on to the next stage, from about 2 to 7 years, called the preoperational stage. Here, children begin to use symbols and develop egocentric thought, meaning they often see the world primarily from their own perspective. They start to engage in more imaginative play and use language to represent objects and ideas. Finally, for children aged 7 and older, the concrete formal stage, they develop the ability for logic and abstract reasoning. They can think more systematically about concrete situations and start to understand concepts like conservation and classification. This stage marks a significant leap toward more complex and abstract thinking. Connecting these stages to our overall theme, it's fascinating to see how children's thinking evolves from basic sensory experiences to complex reasoning. Piaget's model helps us understand the natural progression of cognitive development in children. Let's talk about how language and technology serve as mediating tools for our thought processes. These cultural tools shape how we think, learn, and solve problems. One key idea here is learning from a more knowledgeable other, or MKO. This could be a teacher, a peer, or anyone who has more expertise in a particular area. The MKO provides temporary support, which is essential for guiding us through new or complex tasks. This support is often called scaffolding, and it helps us build understanding step by step. Now, a crucial concept connected to this is Vygotsky's zone of proximal development, or ZPD. It's essentially the space between what we can do on our own and what we can achieve with help. The ZPD highlights the importance of social interaction and guidance in learning. When we receive support within this zone, we're more likely to develop new skills and deepen our understanding. Overall, these ideas underscore how social and cultural tools, like language and technology, are central to mediating our cognitive development and learning processes. Cognitive development is not happening in a vacuum. It's deeply influenced by our historical, cultural, and linguistic backgrounds. When we talk about language as a cognitive tool, we're emphasizing its role in shaping how we think, solve problems, and understand the world around us. It's not just about communication. It's a tool that actively influences our mental processes. Now, these tools are socially embedded, meaning they develop within a social context. Our interactions with others, the environment we grow up in, and the cultural norms all play a part in shaping how we use and develop these cognitive tools. Cultural influences are especially significant because they provide the framework and values that guide our thinking and language use. So, when we consider cognitive development, it's essential to see it as a dynamic process, molded by the broader social and cultural environment, with language serving as a crucial bridge in that process. This interconnectedness helps us understand why cognitive growth varies across different communities and contexts. Let's explore the differences between extrinsic and intrinsic motivation. Extrinsic motivation is driven by external factors like grades, rewards, or pressure. It's often effective for short-term tasks where immediate outcomes matter. However, this type of motivation tends to focus on external validation rather than the learning process itself. On the other hand, intrinsic motivation comes from within. It's fueled by curiosity, genuine interest, and enjoyment of the activity. When you're intrinsically motivated, you're more likely to engage deeply and persist longer because you find the activity itself rewarding. Understanding these differences helps us see why fostering intrinsic motivation can lead to more meaningful and lasting learning experiences, which aligns with our overall goal of encouraging deep engagement and personal growth. Let's take a closer look at the 3 fundamental needs identified by self-determination theory: autonomy, competence, and relatedness. First, autonomy, or the need for choice, reflects our desire to feel in control of our actions and decisions. It's about having the freedom to choose what we do, which boosts motivation and engagement. Next is competence, or mastery, which is our need to feel effective and capable in our activities. When we master a skill or overcome a challenge, we experience a sense of achievement that fuels further growth. Finally, relatedness, or connection, highlights the importance of feeling connected to others, supported, and understood. These 3 needs are essential because they underpin our intrinsic motivation and overall well-being. Connecting this to our broader theme, understanding these needs helps us create environments whether in learning, work, or personal development, that foster genuine motivation and fulfillment. Now, let's talk about budgeting for a dream trip, which ties into our broader theme of engaging and motivating students through effective strategies. First, relevance is key. Making sure that the activities and projects connect to students' real lives helps boost motivation and understanding. Linking classroom work to real-world contexts makes learning more meaningful. Timely and specific comments are also crucial. Giving students immediate and focused feedback helps them stay on track and feel supported. Supporting their competence by providing them with tools and guidance builds confidence. Feedback loops, where students receive ongoing input, keep the learning process dynamic and responsive. When selecting project formats, consider options that foster autonomy and voice. Allowing students to choose how they approach their work enhances ownership. Choice boards are a great example. They give students options and encourage independent decision-making. Leaderboards for math drills add a gamified element that can motivate students to improve through friendly competition. Incorporating points and challenges further gamifies the experience, making learning fun and engaging. A classroom example could be a project where students choose their topics, set goals, and track their progress with a leaderboard. The mechanism here involves clear rules and rewards, while the strategy focuses on maintaining engagement through ongoing challenges. Ultimately, employing engagement strategies like gamification transforms routine tasks into exciting experiences. By blending these elements thoughtfully, we create a classroom environment where students are motivated, autonomous, and eager to learn, turning even budgeting a dream trip into a powerful learning adventure. Let's explore how we can effectively combine different teaching methods to enhance learning. On this slide, we see that match behaviorist methods for skills, meaning that these are great for teaching specific, measurable skills through repetition and reinforcement. Conversely, for deep concepts that require understanding and critical thinking, constructivist methods are more appropriate because they promote active learning and exploration. The learning objectives guide us to focus on the goal, which is to create a strategic combination or mix of these approaches. This mix allows us to leverage the strengths of both methods, tailoring our teaching to different types of content. Finally, the idea of theory integration ties everything together. By integrating these theories, we can design more effective, balanced instructional strategies that foster both skill acquisition and deep understanding. This overall approach aligns with our broader goal of creating engaging, comprehensive learning experiences. Now, let's talk about how we can use multiple frameworks to reach every learner effectively. First, addressing individual needs means tailoring tasks to match each student's developmental stage, drawing on the ideas of Piaget and Vygotsky. This helps us ensure that the learning is appropriate and engaging for each child. Next, we recognize that students come with diverse levels of readiness, interests, and profiles. By considering these factors, interest and readiness, we can create a more personalized learning experience. The key equation here is that differentiation equals understanding each student's profile, their interests, and their readiness, and then adjusting instruction accordingly. This is what we call differentiated instruction. It's about meeting students where they are and guiding them forward, using a variety of strategies to make sure that every learner is supported and challenged appropriately. Ultimately, this approach allows us to be more responsive and effective in our teaching, ensuring that all students have the opportunity to succeed. Now, as we come to the final slide, let's look at how different learning theories come together to give us a comprehensive understanding of effective education. First, we have the social or interactionist approach, which emphasizes the importance of social context and interaction in learning. It highlights that we often learn best through collaboration, discussion, and shared experiences. Moving on, constructivism focuses on meaning-making, how learners actively construct their own understanding based on prior knowledge and new experiences. It's about learners building their own mental models. Then we have cognitivism, which centers on memory processes, how we encode, store, and retrieve information. This theory underscores the importance of mental processes in learning. Behaviorism, meanwhile, stresses skill development through reinforcement and practice, shaping behaviors through external stimuli. When we synthesize these perspectives, we see that effective learning involves social engagement, active meaning construction, cognitive processing, and skill acquisition. Ultimately, understanding these interconnected theories allows us to design more holistic and impactful educational experiences. So, in conclusion, embracing this integrated view helps us better support diverse learning needs and foster meaningful growth.